Hello everyone, good to see you. Welcome to the Huawei HCIP OpenELR Certificate course, and I'm the Huawei trainer Peggy. In this course, let's learn the first chapter of the Huawei HCIP OpenELR Certification course, OpenELR Common Service Management.
With the development of the Internet, more and more applications are running on the web, and the web server has become the key roles to support all of these. In today's course, we will learn how to use ELR OS to build our own web server. Through this process, you will know not only the deep understanding of how web servers work, for example, the Apache, Nginx, and DNS and MySQL working principles, setup and configuration information, but also the knowledge of OpenELR. Okay, let's see the first chapter, the web service. Actually, with the development of the times, traditional industries have begun to embrace the Internet, which can improve working efficiency and reduce production costs. During the electronization and informalization, various software applications are developed. The architecture of these software applications can be classified into CS architecture and BS architecture. And for CS architecture, the user needs to install the client, and many times they are not the common client. So it means you need to install as many clients as you have software applications. But for BS architecture, it indicates that the browser is used to access service. Users only need to install one browser. All services can be accessed by entering the IP address of the server. Therefore, the BS architecture becomes more and more streamlined and is used to carry web service. It is also becoming more and more important. So today, we will focus on the basic setup and configuration of OpenELR-based web servers. The Internet is used to connect the global network. When enterprise or individuals put their own web service on the Internet, it becomes one of the World Wide Web. The World Wide Web system composed of all resources and information on the interconnected network. When users access the resources, they need to input the address. All of this address will usually use www, 3W, that is World Wide Web. And when accessing resources on the Internet, a user needs to know a complete address in addition to starting with 3W, that is the URI. The URI many times we can classify it into URL and URN. If the user clearly knows the Internet location of the resources, that is URL. For example, 3w.huawei.com. If the resource's location is unclear, the URN is used. For example, P2P download. In the future, we will more focus on the URL, which is more higher frequently be used. The URL architecture as follows. Let's see. The scheme indicates the portal used to access resources, for example, HTTP, FTP, or others. User and password indicates the authentication information required for accessing these resources. And the host indicates the IP address or domain name of host where the resources is located. And for port, it indicates the port used by the host to provide the resources. Next one, path, indicates the path of the resources. Attention is needed here that the path may not be the actual path of the resources in the host, but the path provided by the host agent to find the resources. Okay, here we still have some parameters haven't introduced to you when we introduce the cluster resources for chapter 2. We will learn that the rest of the content in this parameter. Okay, now with the URI, the user can access the corresponding resources, but how the resources is presented to the user becomes a new problem. And HTML was created to solve this problem. It is the format standard for displaying resources in the browser. According to the HTML standard, the resources accessed by user can be displayed in the browser in a beautiful and neat manner. So, how do these resources get from the server to the user? This uses the protocol mentioned in the URL. And since we were mainly talking about web services, the HTTP protocol is what we will cover in this chapter. Okay, for knowing more HTTP knowledges, the first one we need to know the HTTP working principle. The working principle of HTTP protocol is very simple. Let's see this picture. The client initiates a request, and then the server sends a response after receiving the request. One request and one response constitute one HTTP transaction. The user continuously requests the required resources and continuously initiates request. The server continuously responds to the request, and finally, multiple HTTP transactions are formed. Actually, the server performs a series of operations in response to a request. So let's see this picture. First step is to establish a connection. The client sends a request for establishing a connection to the server. In the second step, the server accepts or rejects the request according to the access rules set by the administrator on the server. If they refuse, the visit is over. If the server accepts the request, it reads the HTTP request from the network message and processes it. And then this brings us to step 3. The server parses the request package and takes corresponding actions. For example, reading the request resources from the storage. After reading the request resources, the server constructs a response packet and sends the packet to the user over the network. Finally, the server records the transaction in the log. Okay, that's all the HTTP request process. And after that, next question is, what is the characteristics of HTTP service? Here, let's see them one by one. The first one is unidirectional. That is, an HTTP transaction can not only start from the client, and a connection established request can only be sent from the client to the server, but cannot be initiated from the server to the client. Second, HTTP is the stateless protocol. This indicates that each HTTP transaction is independent. After the server responds to the request from the client, the transaction ends and the connection between the client and server is closed. This type of connection is also called non-persistent connections. When the client requests the resources next time, the client needs to send a request again and then re-establish a connection with the server. This mode is usually used in multiple scenarios such as websites. However, when there are a relatively large quantity of resources, efficiency of this manner is very low, and some other problems also will be occurred. So another connection mode is that when the HTTP closes a transaction, the connection between the client and the server is not closed. This type of connection is called persistent connections. The connection is mainly used in scenarios which the client and the server are frequently connected, such as database connections. And finally, the third feature is that the HTTP transmits data in plain text. This mode has high transmission efficiency but may cause information leakage. Therefore, this mode is not recommended now. In the future, we will introduce HTTPS, that is an encrypted HTTP transport. It will be more safety. So, what has been the evolution of HTTP? Actually, HTTP has gone through several iterations since its birth. The earliest version was HTTP 0.9, which supported only the GET method. And 5 years later, HTTP Generation 1 was released. It's adding POST and HEAD method, but it's only supporting non-persistent connections. In the second year, HTTP version 1.1 was released, adding new methods such as put, patch, options, and delete, and so on, and supporting the persistent connection. So version 1.1 was used for a long time, but it was not until 2050 that the HTTP Generation 2 was released. This version is based on speed upgrade, including the header information compression mechanism, server push, and other functions. Well, this version uses multiplexing mechanism in the connection. The client and the server can send multiple requests or response at the same time and do not have to corresponding in order. This avoids the hand-to-hand jamming problem. At present, almost all HTTPS use this version, and also we will learning this version. And then in the 2022, HTTP Generation 3 was released, and its biggest feature is that it uses UDP as a proxy for TCP, resulting in lower latency. For HTTP message, the HTTP message can be classified into request message and response message. They have the same format. It consists of 3 parts. First one, start line, and then header field, and final one, the body. The first line of the package is start line. It contains the method, the URL, and the HTTP version in the request message. It is used to describe the operations to be performed on the server. And in the response message, it contains the HTTP version, the status code, and the short information which is used to describe what happened in the response to the request. And the header field can be empty or contain multiple fields. The format is field name, colons, volume. Multiple fields must be separated by line breaks. The header field ends with a blank line. The content after the blank line is the main part, that is the body. The body of the request message, it contains the data to be sent to the server, and the body from the response message, it contains the data to be returned to the client. The body can contain arbitrary binary data, such as text, images, video, or the other information. This also means that we can perform many types of operation through the web server. And besides this, as we mentioned earlier, HTTP also supports a variety of methods. Here are some of the common methods we need to know. First one, GET. This is the most common method used to request a presentation of the specific resources. GET requests are only used to get data from the server. The body of the request message can be empty. Next one, POST. This method is used to submit data to a specified resources, such as submitting a form or uploading a file. The data is contained in the request body. A POST request may cause a state change on the server. And third one, PUT. This method is used to upload the latest content to a specific resource's location. If the specified URL does not exist, the PUT method creates a new resources. Next, the fourth one, leave. This method requests that the server delete the specific resources. And next one, hand. This method is similar to the GET method, but the server only returns the header information in the response and does not return the body part of the entity. This method is often used to obtain the meta information of the resources, such as the size and the type of the file. Next one, trace. This method is used to trace the path of the request to the server. And final one, options. This method is used to obtain the HTTP method supported by the server. Of course, each of these HTTP methods has its own semantic and should be used when appropriate. In the previous slide, we have introduced that the plain text transmission feature of HTTP brings certain security risks. Therefore, the HTTPS is born. HTTPS uses SO to encrypt data. Both the server and client need to encrypt and decrypt the data. This process slows down the access speed of users, but the impact is very small and the user can hardly feel it. Actually, there are two ways to encrypt data: symmetric encryption and asymmetric encryption. HTTPS uses asymmetric encryption. The server generates a pair of keys, including a public key and a private key. The public key is used for encryption, and the private key is used for decryption. Therefore, the private key is never transmitted over the network. To ensure the non-legality and reliability of the public key, the server applies for a certificate from the authority, that is the Digital Certificate Authority, CA for short. And after generating the public key, then uses the certificate to sign the public key. Once this is done, the server is ready to use HTTPS for data transfer. And next, let's take a look at HTTPS session process. Firstly, the client sends a request to a server. After receiving the request, the server returns a certificate containing the public key to the client. The client requests the CA to verify the certificate. If the request is illegal, and then the client will generate an alarm, and then the user will choose whether to continue to access. If the request is valid, the client generates a random number and uses the public key to encrypt the random number. After encryption is complete, the client will send the random number to the server. After receiving the random number, the server uses private key to decrypt the random number. At this point, the authentication process for asymmetric encryption is complete. Symmetric encryption will be used later. The server uses a random number to encrypt the data to be sent to the client, and then sends the data to the client. The client decrypts the data using the local random number, and then reads the data.
This section, we have described the three elements of the World Wide Web: URI, HTML, and HTTP. It also describes the working mechanism of the HTTP protocol, request access process, features, package structure, and request method. It also describes the principles and session process of HTTPS. Next, we will introduce a typical HTTP application web service. Thank you for watching.